Welcome to Two Projects. In this video, we are going to explain the project Decentralized Social Media. Introduction. In this project, we want to change how social media platforms operate. Instead of relying on one central server, we distribute the responsibility to many computers. Centralized systems have a single point of failure. If that central server gets hacked or crashes, the whole system can fail. And most social media platforms today face certain problems. Data security is not always guaranteed. Control over personal information is limited and there is an abundance of advertisements. Therefore, we are using blockchain, which is like a secure digital ledger, to fix these issues. Blockchain is known for its security. It is hard to hack, and once data is in it, it can't be easily changed, which makes it great for keeping the information safe. It spreads data across many computers all over the world rather than storing it in one place. Even if some of these computers fail or are attacked, the data remains secure and accessible. This decentralization makes hacking much more difficult. Blockchain has several advantages. It is secure due to strong encryption. It accelerates encryption-decryption processing time, and once data is added, it is nearly impossible to change. We are using Ethereum, which is a kind of blockchain. Ethereum allows us to create smart contracts, which are like digital agreements that run on the blockchain. These contracts make sure things happen as they should without relying on a central authority. Therefore, this project's core aim is to transition from centralized to decentralized social media effectively, addressing traditional data security and privacy concerns. It accomplishes this by leveraging blockchain technology, particularly Ethereum, to enhance security and transparency and user control. Objective of the project. So, as I have mentioned earlier, the primary aim is to change how social media works. Instead of having one big central computer, we are spreading the work across lots of computers. The aim is to enable users to create, share, and engage in discussions through tweets on the new social media platform. This ensures that individuals can confidently express their thoughts and ideas without concerns about unauthorized access or tampering with their content. When a user wishes to include an image with their tweet, a specialized system known as IPFS is employed to ensure the image security and easy retrieval. We are aiming to enable cross-language access. It enhances the versatility and accessibility of the blockchain-based platform. It means that developers who are comfortable with Java or Python, along with other supported languages, can build applications, integrate features, and interact with the blockchain's contract seamlessly. And our goal also includes designing a website that is easy to navigate. We ensure that buttons and features are intuitively placed, making the usage of our new social media platform straightforward and enjoyable. The design prioritizes user-friendliness, offering a seamless and hassle-free experience for all. Requirements needed to execute this project are hardware requirements: processor of i5 and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements needed are Node.js, Python 3.7.0 and Visual Studio Community version. To execute this project, we have designed a few modules. The first module is New User Sign-up. This module allows new users to create accounts on the decentralized social media platform. Users provide necessary information to create their accounts, including usernames, passwords, and additional details required for registration. It enables the establishment of unique user profiles and access to platform features. The second module is User Login. This module enables registered users to log in to their accounts securely. Users provide their usernames and passwords to gain access to their accounts. It ensures that only authorized individuals can access their profiles and interact with the platform. It enhances security and privacy for users. The third module is Publish and Save Tweets in Blockchain. This module allows users to create and post tweets on the social media platform. Users compose tweets, which can include text and possibly images, and then publish them on the platform. These tweets are securely stored in the blockchain. The last module is View Tweets. This module permits users to access and review tweets posted by themselves and others within the social media platform. Users can retrieve and read tweets whether they are their own or from other users, creating a timeline of content for their reference and engagement. Blockchain integration. Blockchain captures every action on our social media platform, from posting to commenting and sharing, in a way that can't be altered. Additionally, it helps verify users' identities during sign-up, adding an extra level of trust and security. Through blockchain, instead of storing all our data in one place, we spread it across lots of computers around the world. This way, even if one computer has a problem or stops working, the data is still safe because it is stored in many other computers. Posts are securely stored in encrypted form on the blockchain, ensuring that sensitive information remains confidential. This encryption adds an additional layer of protection to user data, making it highly secure and resistant to unauthorized access. Our platform employs smart contracts coded in Solidity, a language designed for the Ethereum blockchain. These smart contracts act as digital agreements with transparent predefined rules. They ensure that all platform activities adhere to these rules. And data integrity is maintained in the system through the utilization of the SHA-256 algorithm, that is Secure Hash Algorithm 256-bit. Each block in a blockchain is linked with a unique hash code. These blocks are maintained across multiple nodes or servers. Before storing new records, blockchain verifies the hash code of each block. If any block data is modified, it results in a different hash code, triggering security alarms and ensuring the integrity and immutability of the data. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is social media folder. Inside this folder are Python code files that are intended to be dynamically loaded into the project during runtime. This is social media app folder. This folder comprises a static folder which contains files related to CSS, JavaScript and Bootstrap. These files contribute to the visual and interactive aspects of the application. Social media app folder also contains a templates folder. Within this folder, we'll find all the HTML pages used throughout the project. It includes pages like index.html, home.html and more, representing various sections of the website. And it also contains Python code files that will be executed during the runtime of the application, supporting its functionality. This is Hello 8 folder. In this folder, I have a node modules folder. This folder consists of dependencies or modules needed for the project. Now open .bin folder. This folder often contains executable scripts related to the project's dependencies. So here we can see run blockchain.bat file. Double click on it to start the blockchain. This script will initiate the local Ethereum blockchain for development purposes. It contains commands to start the blockchain environment. Now the blockchain is hosted on the local machine at the local host and the port. So this address allows us to interact with the blockchain using various tools and applications. Now execute the command truffle space migrate to compile and deploy the smart contracts. I'm typing truffle space migrate and hit the enter button. Truffle is a development framework for Ethereum that simplifies the process of compiling and deploying smart contracts. They are deployed on a blockchain network and can facilitate various transactions such as transferring tokens or managing digital assets. Once the migration process is complete, Truffle will provide us with a unique Ethereum contract address. This is the contract address. So this address represents the location of the deployed smart contract on the blockchain. And here we can see gas used. To execute the blockchain OSN Solidity file and compile smart contracts, this is the amount of gas consumed. Now minimize this. This is blockchain OSN file. This file consists of Solidity code. It handles data structures, functions and events with the modifiers for validation. This is manage.py file. It is a command line utility that comes with Django. It provides various commands for managing Django projects, including tasks like running the development server, creating database tables, applying migrations, and more. This is start IPFS bat file. This bat file is used to start IPFS server, which is used to store all public post images, as blockchain itself cannot store images. Now double click on it to start the IPFS server. So the IPFS server has been started. Now minimize this. Now this is the run server.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the Django application. So the Django framework will host the application locally at default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, type index.html at the end and hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Django framework. So here we can see user login and new user sign up links. Click on new user sign up link. So if we are new users, we have to register first. Fill in all these details and click on submit button to sign up. So I'm filling in all these details now. The username would be Ravi. Give the password. Give the contact number. Select the gender. Give the email ID. Give the address. So I have filled in all these details. Now click on submit. So in the red color text we can see sign up process completed and record saved in blockchain. We will create another account. The username would be Kumar. Give the password. Give the contact number. Select the gender. Give the email ID. Give the address. So now click on submit. So we can see the confirmation again, sign up process completed and record saved in blockchain. Now we will log in. Click on user login here link. So we log in as Ravi. Give the credentials of Ravi. And click on login. So we have logged in as Ravi. And here we can see publish and save tweets in blockchain, view tweets and logout links. Click on publish and save tweets in blockchain link. So here we can post our tweets and we can also attach images to the tweets. So the post tweet would be petrol prices are increasing. And we have to choose the image here. Click on choose file. So I'm selecting this image and click on open. So I have selected the image and I have given the tweet. Now click on submit. So in the red color text we can see the tweet saved in blockchain with below hash code and media file saved in IPFS. So the tweet is saved in encrypted format and the image file is saved in IPFS. Now click on view tweets link. So here we can view the tweets posted. We can see tweet owner, that is Ravi, tweet message, the IPFS image hash code, the image is encrypted format, the tweet image and tweet date and time. Now click on logout. Now we log in as Kumar. Click on user login here link. So give the credentials of Kumar and give the password. Now click on login. So we have logged in as Kumar. Now click on publish and save tweets in blockchain. So this time the tweet would be congratulations on the success of Chandrayaan 3. And now click on choose file. So I'm selecting the second image and click on open. So now click on submit. So we have posted the tweet. The tweet saved in blockchain with below hash code and media file saved in IPFS. Now click on view tweets link. So here we can see all the tweets posted, not only ours but also others' tweets. So here we can see both the tweets. Now click on logout. So the conclusion here is we have successfully developed and deployed a decentralized social media platform. Unlike traditional centralized platforms, our decentralized approach ensures that data is distributed across multiple nodes, eliminating the single point of failure associated with centralized servers. By incorporating blockchain technology, we have achieved immutable data storage. This means that once data is recorded on the blockchain, it cannot be altered or deleted. Our platform goes beyond language barriers by enabling cross-language access. Users can interact with our blockchain contract using various programming languages like Java and Python. To efficiently manage images within social media posts, we have integrated the Interplanetary File System IPFS. This integration enables the secure storage and retrieval of images associated with posts. The development of an intuitive and user-friendly graphical interface simplifies user interactions. From user registration and login to publishing and viewing posts, the interface streamlines these actions, making them straightforward and enjoyable for users. And our platform is built to scale. This scalability ensures that as more users join the platform, it remains reliable and responsive.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.